The Mojave Desert, Nevada, USA. A hot, dry, and desolate place. It's mind-boggling to discover that in the middle of this dusty desert is one of the most extraordinary and exciting cities on Earth. Las Vegas. An artificial oasis in the desert. It's one of the biggest electrical extravaganzas in the world. "30 million people visit Las Vegas every year. It's a city completely over the top, where everything is done to excess. Visitors eat a lot, drink a lot, and above all, consume huge amounts of electricity. But the gigantic electricity bill is not just for the lights and entertainment. You can't survive out here in the Mojave Desert without air conditioning. And air conditioning uses a great deal of electricity. So where does the electricity come from to power this huge metropolis? Las Vegas was dealt a lucky hand just over 60 years ago. In 1935, one of the technological wonders of the world was built nearby, the Hoover Dam. It sparked the growth of Las Vegas. Before the dam was built, this whole area was dry for one half of the year and flooded for the rest. Las Vegas was just a dusty old town. But the Hoover Dam changed all that. It provided constant water and electricity to the surrounding areas. The Hoover Dam put Las Vegas on the map. Dam workers and their families flooded into Nevada. It was one of the few places they could get work during the Great Depression of the 1930s. When the Hoover Dam was finally finished, it tamed the great flow of the Colorado River and used the energy from the gushing water to provide endless electricity for parts of Arizona, California, and Las Vegas. The Hoover Dam spans 220 meters from its foundation to its top. The dam's generators can produce up to 2,000 megawatts of electrical power. That's 2,000 million watts. When the dam was built, the huge concrete crescent trapped the water flowing down the Colorado River to create Lake Mead. It's the biggest artificial lake in the USA. Many dams have water cascading over the wall, but here the water from Lake Mead drops down 4 intake towers. The pressure of the falling water turns the turbines that drive the generators to make electricity. Water flows down the pipes hidden in the canyon walls. It enters the building that houses the turbines and generators. The flowing water spins the turbine blades. The turbine is connected by a shaft to the generator above it. Turbines turn the generators to make electricity. The water that has been churned through the turbines from Lake Mead is finally returned to the Colorado River. You have to descend 160 meters deep down into the Hoover Dam wall to reach the generators.
We're overlooking the wing of the Nevada power plant. Now from here you can see there are 8 generators. On the Arizona side there are 9. The turbines are located directly below the generators, 2 stories below us.
But how do the generators make electricity? A voltage is generated or induced in a coil of wire when a magnet passes through it. If a magnet rotates near a coil of wire, an electric current is produced in the wire. The rotation of the magnet produces alternating current. That means that the current is continuously changing direction.
We're on top of a 600-ton magnet that goes all the way around the generator, and it's attached to the shaft. Above and below the magnet are coils. And as the magnet moves around the coils, it produces electricity in the coils.
The Hoover Dam generators produce alternating current. That's because they have a rotating magnet which changes the direction of the current. The power output of a generator is measured in megawatts. One generator is producing 100 megawatts, which is 100 million watts. That's enough to power 1,000,000 100-watt light bulbs. The generators are directly linked by wires to transformers outside the building. The wires from the generators are fed through these silver tubes into the transformer. The voltage is stepped up from 16,500 volts AC to 230,000 volts AC. This is done to reduce the loss of energy during transmission along the lines.
Well, the power travels through these high voltage lines to the towers. Now, the reason the towers are at angles is so the wires don't touch the canyon wall. Now, tracing those wires, you can see they travel to Los Angeles, Phoenix, and Las Vegas.
The wires are divided into different directions at a distribution center. At this point, the wires are carried by great pylons perched along the horizon to the surrounding towns. It's not just the Hoover Dam that supplies Las Vegas with electricity. The company Nevada Power has many additional power stations dotted around the city, which run on gas and coal. These fossil fuels are burnt to heat water to produce steam. The steam then drives the turbines, which turn the generators to make electricity. The electric current from these power stations also flows down the overhead cables heading for Las Vegas. The high-voltage electricity arrives in Las Vegas without too much power loss. But 230,000 volts is extremely dangerous to use in homes and hotels. So it goes to a substation, where it's stepped down by various transformers, from 230,000 volts to 12,500 volts. It's then sent to nearby hotels. A little bit of ancient Egypt comes to town. This fun-packed pyramid is one of the biggest hotels in the world, with over 4,000 rooms. Its demand for electricity is like that of a small town. The Luxor offers a pharaoh's welcome to over 8,000 guests, creating a huge demand for electricity.
Okay, we get our power from Nevada Power Company. We have 2 feeds into the hotel. It comes in at 12,500 volts in cable like this one here. It comes into 2 main switches. From these switches, it goes on into a line of switches inside of this room here. And from there, it's distributed to various transformers and all around the hotel here.
The Luxor Hotel needs its own bank of transformers to step the high voltage alternating current down to various voltages.
Okay, you're seeing 3 big coils in there. That reduces the 12,400 volts down to 4,160 volts. This is the power that we use for our air conditioning units. And then it goes to another bank of transformers that breaks it down to 120 208 volts that we use for lighting and for slot machines, gaming, and whatever else it might be.
But for the folks who don't have a home with 4,000 rooms, they don't need so many transformers. One is usually enough to get yourself hitched to electricity. This transformer steps the voltage from the substation right down to 110 volts AC. These transformers are dotted all over Vegas, from the famous Vegas Strip to the suburbs. If it wasn't for this routine of stepping up and stepping down, most of the electricity would be lost before it got to Vegas. Electricity is generated at 16,500 volts AC, stepped up to 230,000 volts AC by a transformer and sent long distances down the power lines. Then it's eventually stepped down to 110 volts AC before it gets into homes. But why bother to step the voltage up and then down? 230,000 volts is extremely dangerous. Stepping it down to 110 volts AC is much safer. But why step it up in the first place? Why not just generate and transmit the alternating current at a much lower voltage? If they did that, there'd be a big problem. To transmit electricity at low voltage, the current has to be high to compensate for the low voltage. And high current heats up the wires. This is an infrared image of the wires at low voltage AC. They appear white because they're hot. With high voltage and therefore low current, the wires barely show up because they're not so hot. Heat wastes energy, so if we transmit it at low voltage and high current, we would end up with less electricity reaching our home. So, if heat wastes energy, then surely the lights of Vegas must consume vast amounts of electricity.
By looking around the city of Las Vegas, one would think that the energy consumption of all the neon lighting in Las Vegas would just be incredible. Quite frankly, though, they found out several years ago during the energy crisis, they initiated a provision that all the hotel casinos would have to turn off their lights at a certain time in the night. What they found out by this after a period of doing that is that the actual power consumption of the lighting around Las Vegas was only the equivalent of about 2%.
These two bulbs are both producing the same amount of light. The filament bulb is a 15-watt bulb, but the neon light is only 5 watts. Using an infrared camera, we can see that the filament bulb on the left is producing more heat than the neon light. So the filament bulb is wasting electricity by producing heat.
The filament type lighting, which produces a lot of heat, is a lot less efficient. To put that a little bit into perspective, if you were to take this 4-meter section of neon, it would be approximately the equivalent of about one 100-watt light bulb.
Neon lights work in a completely different way to ordinary filament bulb lights. The crucial difference is that neon lights don't have filament wires that glow white hot. If there's no filament in neon lights, how do they glow? Once the hoteliers have decided on the look of their neon light, work can begin on a new neon light creation. Electrodes are fixed to the glass tube at each end. These allow the electric current to flow through the gas, causing the gas to glow. The glass tube is gently manipulated over a naked flame to produce a shape. Air is continually blown into the tube to stop it squashing as it bends. The hot glass is so flexible that it's easy to bend into a design. You can use clear or coloured glass, whatever takes your fancy. A pump is used to remove all the impurities that might have got trapped inside the glass tube. The tube is heated using a high voltage AC supply to shift any remaining dirt. The tube is then left to cool down. The tube is filled with neon gas. A rainbow of colours can be produced by using different gases. The colours are produced when the current flows through the gas. Argon gives purple. Neon gives red. Helium, very pale blue. Krypton, silvery white. And xenon, deep blue. Put the gases in coloured tubes coated with chemicals and we can produce more colours. A blue glow in a white tube gives white light, but red glow in a white tube gives tangerine. Las Vegas owes its very existence to the Hoover Dam. If it wasn't for the dam, this whole area would still be a barren desert. Like all big cities, Las Vegas is not environmentally friendly, but the Hoover Dam doesn't contribute to the general atmospheric pollution. Most of that comes from the cars. The advantage of using hydroelectric power from the Hoover Dam is that it reduces the total amounts of fossil fuels that would need to be burnt to produce electricity. This in turn reduces atmospheric pollution and helps to prolong stocks of fossil fuels. Coal, oil and gas will probably run out in the 21st century, but the Hoover Dam is designed to last 2,000 years.